Icebreakers play a vital role in keeping shipping lanes open around the poles, but you might be surprised to find out that you can also find them in the subtropics. Stretching roughly across the same latitude as Italy, you wouldn't have thought that the Caspian Sea freezes over, but it's a fact that the Rosmor port is all too aware of given its task of keeping Russia's waterways open all year round. With the waters of the Caspian and Azov Seas being particularly shallow, its fleet of aging icebreakers made in the 70s and 80s no longer cut the mustard.
Shallow waters present their own specific challenges, like the excessive number of ice ridges, for example. At times, overcoming these kinds of natural obstacle is even harder and consumes more time and energy than navigating in the harsher conditions of the northern and Arctic seas. And that's why working in the Caspian and Azov seas requires extra attention and special skills and technology.
So, if you're in the market for a new icebreaker, your first port of call should probably be the Krylov State Research Center. With over 120 years in the business, you'll struggle to find somewhere with more expertise. Many of us remember playing with toy ships when we were young, but it looks like some of us never grew out of it. The only difference at the Krylov Center in St. Petersburg is that the bath is over 1,300 meters long and the ship model's over 10 meters in length. In fact, this towing tank is the largest in the world. It's so long that the rails on either side are even bent ever so slightly to take into account the curvature of the Earth. And believe it or not, but this enormous testing pool is just a drop in the Krylov Research Center's technology ocean. Today, the Krylov Center employs some 3,000 people, including 300 scientists and researchers. Sprawling over 800,000 square meters, the center has 8 testing pools filled with enough water to make you seasick, 5 cavitational tunnels, 2 aerodynamic tunnels, and to top it all off, 1 U-3 research nuclear reactor.
Let's go, 1.85 meters.
Going forward, 185.
During its time, the centers tested the seaworthiness of over 12,000 model ships of all shapes and sizes, and at 1.6 meters a second, we were moving just a tenth of the maximum speed of what this sci-fi looking towing carriage is capable of. Each model is packed to the gunnels with sensors including dynamometers, gyroscopes and accelerometers to measure the resistance, stability and acceleration of the vessel. The tendency in the tech world may be for things to get smaller, but that's not the case when it comes to modelling ships. So, the bigger the model, the more realistic the test, and the less the results have to be scaled up afterwards. Rosmor Port expects to use its latest ship all year round, so the Krylov Institute had to find the sweet spot between icebreaking and seafaring. But before anything hits the waves, every porthole, rivet and weld is plotted and tested on computer. And the Krylov Center really pushed the boat out this time.
This shallow draft icebreaker is a uniquely powerful ship given its very limited draft. It has power of up to 6,400 kilowatts fed to the propellers.
When we talk about Russian icebreakers, the iconic nuclear Arctica-class ships instantly spring to mind. They're the largest, most powerful icebreakers in the world, and Russia currently has 3 of them in its fleet. Generally, this type of icebreaker can be identified by its curved, pointy bow, 2 nuclear reactors and 3 propellers capable of crunching and cracking through ice up to 5 meters thick. But using this class of ship on the Caspian Sea would not only be overkill, it would likely run aground in the shallow waters. An entirely different class of ship is needed to suit these conditions. The Krylov Center's latest shallow draft vessel has an optimized bow angle and shape to maximize the icebreaking capabilities within the limited water depth. This combination of shape, along with the 2 fixed and 2 pod drive propellers, means that the icebreaker not only has a draft of just 3 meters, but can still punch through ice up to 1 meter thick. The Krylov Center is constantly updating its technological and industrial capabilities to meet demands for faster, more accurate ship modeling, which have increased significantly over the decades. Its reputation for producing top-notch models quickly has led to countless orders from ship designers looking to see if their ideas are watertight. The centre's in-house model building facility is one of the first stops on our tour. But surely these days it will be much cheaper and easier just to do it all on computer.
Calculations alone don't give the required level of precision. The thing is, precision requirements are becoming stricter and stricter, and they can't be met by only using software. Many engineering companies make the mistake of foregoing model trials and trying to replace them with computer projections. Unfortunately, nothing good ever comes out of this.
The centre's giant 5-axis milling machine is capable of making ship models up to 13 meters long and 3 meters wide. They're made from a combination of extruded polystyrene foam and wood, which makes it easy enough to work with while providing enough strength to cut through the waves in the towing pool. Depending on complexity and size, it takes between 3 to 5 days to carve out each model, and over the last 8 years, this machine has churned out around 350 of them. But the shape of the vessel would mean nothing without the propeller. To start off with, standard screws are used in the towing pool to understand the water dynamics and speed around the area of the hull where the final propeller will be installed. Based on this information and the required speed and operating depth of the vessel, a customized 3D model propeller can be drawn up. Special software works out the optimum way to create the prop before sending it over to be made on yet another milling machine. Given the massive power of the shallow draft icebreaker's engine, its propeller will have to withstand huge forces while minimizing cavitation as much as possible. Also, with some shipping companies spending tens of millions of euros a year on fuel, any small percentage increase in propeller efficiency can lead to huge savings out on the waves. The measurements of the steel model prop compared to the 3D model are checked with a precision of 5 microns with the help of a laser coordinate measuring machine. If there's any deviation outside the acceptable range, the propeller may be sent back to be reworked or completely remade.
We also conduct trials in a wind tunnel, where we study how the air flows around and interacts with the ship's superstructure and the top side of the hull.
Optimizing the areas of the ship directly exposed to the wind not only improves performance, especially in severe conditions, but also improves fuel consumption. The engineers also have to make sure that gas or diesel emissions from the funnels don't flood the icebreaker's structure or decks, making it hazardous for the crew to be there. Up until 1936, Russian icebreakers were built exclusively at foreign facilities in countries such as Finland, Sweden and Denmark. Since then, icebreaker construction in Russia has been developing at a rate of knots. With a total of 13 manufacturing facilities, Port City St. Petersburg has become one of the engine rooms driving the country's shipbuilding industry forward. Russia currently has the largest icebreaker fleet in the world, and with documents for the Krylov Center's icebreaker expected to be approved soon, the fleet will hopefully have another shallow draft vessel among its ranks in the next couple of years.